All right, here is section 3.1. This video is for the first exercise, and I just want to make sure that you are doing this one on your own, because there's a lot you can learn from this one especially. So let me just get you started with the first little bit. So let's say, so we're supposed to fill in this table for each function and then sketch the graph of each function. So with the first one, we have f of x is 2x squared minus 5. So what's going to go in here, when x is -2, we're plugging that in here. So it's 2 times -2 squared minus 5. And remember that -2 squared means -2 times -2 multiplied by itself 2 times. That's -2 squared. And there's still the minus 5 there. And -2 times -2 is positive 4, because a negative times a negative is a positive. So you got 2 times 4, and then that minus 5 gives you 8 minus 5, which is 3. All right, so that means this one has the point -2, 3 on it. So if this is a graph of f of x, -2, 3, x equals -2, y equals 3 is right here. So that's one point. If you were stuck, then what I want you to do is do the rest of these on your own, and don't unpause the video until you're done with them, and try graphing them, because this is a really important thing to do. So anyways, let's pause it right now. I'm going to whistle while you're paused. All right, welcome back. So for the rest of these, let's check these answers. This is going to become -3, -5, -3, 3, and then 13 here. I'm just going to fill in the rest while I pause my recording to make it a little faster. So these should be the answers you got, so let's check them. Did you get 3, -3, -5, -3, 3, and 13? When you plot those xy points, it should look like these points I have plotted, and I'm just connecting them with a smooth curve to make the graph of that function. And same thing here with g of x. We got -2, -8, -1, 0, 0, 4, 1, 4, 2, 0, and 3, -8. When you plot those points, it should look like this. There's a couple things I want to point out, which is that 2x squared minus 5, when you plug in these numbers, you're always doing something minus 5 here. And that 2x squared part of it is always positive. Like here, like for example, even when we plugged in -2, squaring -2 makes it becomes positive. So this gives you a result that's always something positive minus 5. So you can see the results, the y coordinates here, always come out to be -5 or greater. And there's something else interesting about this other one, which is, notice when there's the x plus 1 here. When you plug in x equals -1, this part became -2 times -1 plus 1 times -1 minus 2. And this part becomes 0. So the whole thing becomes -2 times 0 times -3. And multiplying a bunch of stuff by 0 always makes the result come out to be 0. And what about this other part here? Because this is written in this factored form. We're just multiplying these three things together. What value of x makes it so that x minus 2 is 0? That would be x equals 2. And when you plug that in, that makes this whole thing come out to be 0 as well. So that's something special about the way this is written. Something else I want to point out about this is that this can be written in the form, if you were to FOIL out the x plus 1 times x minus 2 part, the whole thing would turn into negative 2 times x squared, and then we're going to do that's x times x times negative 2 is going to become minus 2x, and then we're also going to do plus 1 times x, and then also 1 times negative 2 gives you a minus 2. And then when you distribute the negative 2 in there, you get negative 2x squared plus 2x and then plus 4 when you work it all out. The thing about this is that it ends up having x squared in it, because when you FOIL it, you end up doing x times x. So both of these are examples of quadratic functions, and we're going to see in the next example video, I'm going to give a definition for quadratic functions, and we'll talk about it then.